Welcome back to the Y and delta connections. Okay, so let's draw the configurations. The circuit here, plus minus here. Node N, A connected to delta load. So this is VAN still, okay, VCN, VBN, okay, and it's connected to a delta load. So this is your Y delta connection for three-phase system. Okay, so Z delta, they're balanced, so they're the same. Let's call it Z delta. Okay, so Y on the source side and delta on the load side. Y delta connection. Right, so let's see. This is of course A, right? This B right here, small b, small c, this capital C. Okay. So I line is here, right? IAA, IBB, and ICC. Okay. The line current would be IAB, the phase current on the load side, okay, IAB, IBC, and ICA. It's like AB, BC, and then CA in that sequence. Okay, so given, most of the time it's always given, just your source, given a ABC sequence again, ABC sequence, so therefore, right, VAN is equal to V phase 0 degrees volt, VBN is equal to V phase minus 120 degrees volt, and VCN is equal to V phase positive 120 degrees volt. Okay, of course the line voltage is between line A and line B, so this, right, VAB, VBC, and VCA. So this is your line voltage. So let's try and find line voltage, VAB. So VAB is, again, you walk from point A to point B. So A, so you see positive VAN, your destination B is here. So you see VAN, you walk through VAN, positive VAN, and you walk through a negative VBN. So therefore it's VAN minus VBN. So just like the last clip, right, the last video. So therefore it's equal to V phase 0 degrees, right, minus V phase minus 120, and this answer would be root 3 V phase, right, 30 degrees. And if you remember that, okay, it's balanced, right, so the next one would be the same magnitude, so root 3 VP, and it would be minus 120 degrees apart, so it's minus 90 degrees, right, minus 120. The last one, VCA, right, same magnitude, right, and but the phase angle is from the first one to the third one is plus 120, so you add 120 degrees, so you get 150 degrees. So this is your phase voltage VAB, VBC, and VCA. Okay, right. Then, okay, now you want to see the line. You want to find the line current. But before that, let's realize something. On the line voltage, VAB, if you trace it across the phase on the load side, right, this point here is the same as point here, point A, right? Point B here is at point B. So actually VAB of your line voltage, VAB, right, plus minus VAB like this, right? It's the same thing as the voltage across your impedance, AB. You see that? It's the same point. This point here and this one right here. Same thing. So therefore, we can say that in this case, V line, right? V line. Okay, this is V line, right? Okay, V line is equal to V drop across the phase on the impedance side, VZ. Okay, so the current on each line, right? IAB, IAB is like this. So IAB, let me reduce a little bit so you can see what I write. So IAB, right? The current in each phase at the load side, IAB, would be VAB over Z delta. Okay, right? And VAB is, of course, root 3, right? VP 30 degrees over Z delta. And just use your calculator. Okay. IBC would be the voltage drop across BC over Z delta. What is voltage drop across BC? So VBC is plus minus like this. So on the positive side, it's at point B, right? And C, right? It's here. So actually, it's a line voltage between line B and line C. So it's same thing as root 3 V phase, right? VBC minus 90 degrees over Z delta. ICA, so it's a voltage drop across CA, I mean the impedance, okay? VCA divided by Z delta. And of course, here CA, so positive, negative, the voltage drop across this impedance between point C and point A. So the positive is at VC, and this is A, right? C and A line. So actually it's a line voltage at VCA. So it's root 3 V phase 150 degrees divided by Z delta. So use your calculator to get the current. So it's a phase current on the load side. Okay. Now, another parameter we need, the last parameter is I line. I line. Okay. So there's IAA, right? IAA. If you look IAA, I line, look from the picture here. Well, I lines come to this node. Oops, sorry. This node right here. This node here. All right, IAA. IAA. Well, it's a combination of ICA and IAB. So you use KCL. You use KCL, right? Current in equal to current out of the node. So therefore you will get that IAA is equal to IAB minus ICA. So therefore, because so IAA would be equal to IAB minus ICA, right? So KCL on each node. So IBB, right? Line B would be IBC minus IAB, and line C equal to ICA minus IBC. Okay, so these are the line currents. Okay, and of course all these values you know already from here, so you can get the answer. Okay, and when you do it, okay, when you do it, you will find out that, okay, IAA, I line is the magnitude of I line is root 3 of I phase in this case. Okay, and the line current, the phase of the line current, okay, lags their phase angle, the phase angle of the line current lags their phase current by 30 degrees. So I'm going to show you an example. One example in this case. Okay, so this is a conclusion for all the line voltage, line current, okay, and phase voltage and phase current for the Y and delta. Okay, so an example. A balance ABC sequence, Y delta connected with VAN equal to 110 degrees volt and the impedance equal to 8 plus 4J ohms per phase. Okay. Calculate phase and line current. So this is the problem. So if I write down on the generator side, the problem has given one reference, so 110 degrees volt, and it's an ABC sequence, so that means VBN, the next one would be 100, right? 10 minus 120 degrees, so it's equal to 100 minus 110 volt. VCN would be 110 degrees plus 120, so equal to 130 degrees volt. So if you're going to calculate line current, right, line current, okay, VAB, okay, it would be, right, if you do it mathematically with your calculator, it would be VAN minus VBN, right? So it'd be equal to 110 degrees minus 100 minus 110. And when you use your calculator, okay, it will come out to be that VAB then equal to root 3 times 100, and the angle is of course ahead by 30 degrees from your VAN. Okay, but if you calculate your calculator, it will turn out to be 40 degrees. Okay, so it would be 173.2 40 degrees volt. So this is a balance system. So the next one, VBC would be, the magnitude is the same, 173.2, right? The angle would be 40 minus 120. Okay. And the next one, VCA, would be 173.2. The angle would be 40 plus 120. Right? So this would be 173.2 minus 80 degrees volt, and this would be 173.2 angle 160 degrees volt, like this. Okay, right? And from this Y delta case, right? So this is your you got your phase voltage. Okay, this is your this is your line voltage. Okay, we want to find phase current. Phase current in this case, right? So phase current in this case is the current on the load side, the phase on the load side. So it will be IAB. And of course IAB is the voltage drop across that impedance, right? Z delta. And we know that from the configurations that the V line is the same as the voltage on the load side of each phase. So therefore, this is nothing but a V line. So equal to, where is it? 173.2 40 degrees volt divided by the impedance, right? So 8 plus 4J. Okay. And the answer is, use your calculator, 19.36 angle 13.43 degrees amps. Okay. So next one, IBC, right? IBC would be the same magnitude, right? So 19.36, right? And there would be 120 degrees apart. Okay, it's a ABC sequence. So you can answer right away that this would be 13.43 minus 120. Okay. And your ICA, well, of course you can do it mathematically. So IBC would be equal to, right, 173.2 angle minus 80 degrees divided by 8 plus 4J, right? ICC would be 173.2 angle 160 degrees divided by 8 plus 4J. So this one would be 19.36. Angle would be 13.43 plus 120. So this would be 19.36 angle 151 by 120, right, plus 13. 120 plus 13, so 133.43, right? Yes. Okay, and this would be equal to 19.36 angle minus 106.57, about, yeah, amps. Oops, sorry. Amps. Okay, so this is your phase current on the load side. Okay, next one, line current. Line currents, right? So IA, okay, you can say IAA like this, IA, okay, right? So from the if you can look from your configurations, right, what IA is. So IA is IAB minus ICA, right? So IAB minus ICA, right, like this. Okay, so IAB minus ICA. So your IAB is 19.36 angle 13.43 minus ICA 19.36 angle 133.43 degrees. Use your calculator, okay, and it end up you will get 33.53 angle minus 16.57 m. Okay, you get your first answer. You know, balance system make your life it's very easy. So therefore IB would be same magnitude, 33.53, and this would be 16.57 minus 120. So equal to, right, 33.53 angle minus 136.57 amps. IC would be equal to, right, 33.53 angle minus 16.57 plus 120. So 33.53 angle 103.43 degrees. Oh, 43 degrees amps. Should have moved further down. Okay, so this examples very easy. Okay, very simple since you grasp the way you look at your configuration at the beginning. Okay, and since you get your first answer, you can get the second and the third answer right away. Okay, so that's it for the Y and delta connections. Okay.